My name is Haley Strahan, and I'm the Director of Outreach and Student Services for the College of Engineering. And I want to welcome you today to a major discussion for the Department of Electrical Engineering. Our goal today is to answer any of your questions as they relate to what it's like being an electrical engineering student. And our guest today is Dr. Tcheslavski. He is the interim chair of the Department of Electrical Engineering. And on another session, I heard someone kind of describe the chair as sort of the principal of the department. And I thought that was a really good reference point for some of you, because I know sometimes when you're coming into college, you're not exactly sure of the hierarchy and how all that works. And with us also, we have Dr. Zargarzadeh, who is a professor of electrical engineering. And also joining us is Alyssa, who is an LU admissions counselor, and she will be taking any of your admissions questions that just kind of relate to generally Lamar, how you apply and get in. Your video is turned off and your mics are muted to ensure privacy. So if you have any questions, you can use the chat option at the bottom of the screen. Some of you will be answered in the chat. Some of you, we will take that question and let the faculty answer it, but we'll do our best to answer all your questions. We are recording this session and putting it on our website later, so it'll be closed captioned, and you can always go back to it and look at it later. And let's get started. So Dr. Tcheslavski, I'm gonna hand it over to you.
Well, thank you very much, Haley, and everyone, welcome. Good afternoon. And again, thank you for introduction. Thank you for your interest. And Haley mentioned that I'm serving as a chair of electrical engineering department. Sometimes I mistakenly call it electric chair, but again, guilty. So first of all, let me share my screen, this one. All right. Okay. Made a mistake. Here it is. So first of all, what is electrical engineering? Our interest includes everything with electricity or light or both, which means that everything from, say, simple light bulb, although light bulbs are not that simple anymore, up to the most sophisticated computerized systems that may take several rooms are of our interest. By the way, we are very actively using computers, despite some beliefs that electrical engineers only work with electricity. But no, indeed, we are using computers in our research, in our everyday life, in two ways. As a tool or instrument, so we produce code, we produce apps, but also, what is perhaps more important, we use them as building blocks, or we can actually design computers. Well, since we are engineers, we can design electrical systems. And we can design systems that are using computer equipment, using computers as building blocks. Well, for instance, controllers, microcomputers, computers on the chip, maybe parts of much bigger systems. And Dr. Zargarzadeh will be talking about this today, most likely. This is the list of our faculty members at this time. And you may notice that this list shows research interests for every faculty member. For instance, my research interest is in digital signal and, to lesser extent, digital image processing. Dr. Myler, his research is in telecommunication, image, video processing, and actually also a big part in artificial intelligence. Dr. Reddy is mostly exploring alternative energy sources, electric vehicles, other cool green instruments. Dr. Reza, his main research area is in power systems, power grids, smart grids, microgrids, name it. Dr. Sail is exploring VLSI and low power design in general. Dr. Wang is our network specialist. Dr. Zargarzadeh is our control / robotics person, and he'll be talking about his research in a minute. Dr. Togas is exploring antennas and electromagnetic waves propagation in general. Dr. Hirana and Mr. Almulahi are our instructors. So although they do not carry much of research, but still they are active. And Dr. Hirana is exploring memristors, and Mr. Al-Malahi is interested in engineering education in general. Dr. Barim is here because he is our liaison in physics department, and he is our optic person, and in general, he is our physics professor. And at this point, I would like to pass the microphone to Dr. Zargarzadeh. He will share a few details about his research with you, and hopefully will excite you about his projects. Hassan, microphone is yours.
Hello, everybody. Give me 1 second. So I start sharing my video. I'm Hassan Zargarzadeh. I have a PhD in electrical engineering with the focus on control engineering. Currently, I'm an assistant professor with the Department of Electrical Engineering at Lamar University. I direct the Robotics and Intelligent Control Systems Lab. And today, I would like you to have a tour, a virtual tour with me to my lab, and I'll give you some details about what I do and give you some familiarity with the area of robotics, autonomous systems, and mainly drones. So in my lab nowadays, we do a lot of drone projects. So I want to give you the idea that why drones are important. First of all, they are good. I mean, in a humorous way, they're good. We could use them for firefighting and rescue, policing wildfires, and conservation for the wildlife and defense, right? They could also turn out to be bad. There are these days you may hear about suicide drones or drones making security threats and spying and things like that also. And they turn out to be sometimes ugly. So you've heard that, like, one day they'll deliver stuff at our door. So we even don't need to go to the mailbox to pick them up. And they bring pizza at the door and just like so many other stuff. So, I mean, society-wise, they may also turn out to be ugly. So for all of these aspects, they look like to be a fascinating area to be studied from technical, technological, and societal aspects. So the impact of drones on the area of the economy only is that as the following. So I did a research and I found a paper that was published in 2013 by the Association for Unmanned Vehicle Systems International, UAS, that if we integrate them in our system and we start using them, the impact to the economy is going to be $82.1 billion between the years of 2015 to 2025. And just notice that this research was done 2 years before 2015, and now it's 2020. So we are halfway. And you have seen so many changes in the world of applications or robotics, especially the drone. So total job creation is going to be 100,000 only for United States by 2025. And even the manufacturing jobs needed for this area is going to be only is going to be requiring a bachelor degree, at least in electrical engineering. So just imagine if you want to just fabricate a robot, you'll need to have an electrical engineering or a similar degree. The tax revenue for the government is going to be almost $500 million, and basically the focus is going to be for the drones um, is going to be in the agriculture and the public safety. 90% of the market. And now just look at the number that almost 10% of all of these numbers is gonna belong to Texas. So you've heard about electrical engineering and all of those aspects that Dr. Tcheslavski mentioned. One of the smallest branches of the market is robotics right now, and with the electrical engineering, you have a variety of options in terms of application for a job. And just look at the drones, and you see there is going to be 14,000 almost jobs waiting for you in a very near future. So we have brought drones using the achievements that we have in my lab. We have brought the drones to the classroom. So now you could have a drone at home, and it's just like a control laboratory. And then you apply all of those control engineering theories that we teach in one of our courses at home to a drone, and just give it a trajectory to move, and just keep the altitude to stay constant, and so many other maneuvers that a drone can do. All of it is going to be autonomous. So there is going to be no remote. You just program the drone, and the drone will do whatever you desire. In terms of the equipment that I have to do research on the drones in my lab, my lab recently has been equipped with very sophisticated equipment that you could fly drones in swarms. So you could have a bunch of robots, or like say 10 of them, and then you give each of them a trajectory and have them to make a formation or follow a desired trajectory, and so on. So we are so proud that Lamar University supported this to provide this equipment for my lab, and it has turned out to be very productive. We have published so many papers. It has attracted undergraduate and graduate students to the lab to learn about it and research about it. And one day that you come to electrical engineering department, I would encourage you to stop by, and I will show you a live demo. And you could also watch a video if you just look it up on the YouTube. You can see, you can find the link to the video, who is a snapshot only. It's been provided here. In terms of robotics, we have had several other projects that has been performed by undergrad and graduate students at Lamar University. We have spherical robots, and we have hexapod robots, and as you see it right here. And spherical robot. These robots are very complicated in terms of the dynamics and kinematics, and just in terms of the equations that you have to write. So you know how to control them, how to make them to follow a desired path, and so on. So we have done so many research on them, and we have been kind of pioneering in this area. And the result of the research has been published in very good journals. So this is a closer picture of the spherical robot that is unique to Lamar University. Nobody else has made or kind of our invention. And you see that the kids are simply using a remote to control it, but to make it autonomous, it takes a lot of challenge. And we have been able to take this challenge and overcome it and publish papers based on that. And this should be, I have to say, thanks to undergraduate students who collaborated to manufacture the robot, do the electronics of it, and graduate students who did the advanced part of the control design and so on. So this is our hexapod, and it's being controlled autonomously by one of my graduate students. On the right, it's me, and on the left is one of our graduate students. And this is our the team who was working at my lab 3 years ago. So at last, I would like to introduce to you the certificate that the Department of Electrical Engineering offers, kind of for free. You just take your degree, bachelor degree from our department, and if you wisely choose your elective courses, you will get the certificate for free. It's very exciting. So the history behind it is that we learned from our collaborations with industries, especially refineries, that the electrical engineers mostly are hired in the refineries as instrumentation and control engineers. So we did a good research and found that there are some courses that they have to pass so they could be ready and have a kind of a head start from other university graduates when they go to these jobs. So we developed a three-course, basically just three-course um, certificate that comprises of electives that you just have to take, but you just choose what to take, and then based on that, the certificate will be complete and you will get it. So what is the benefit of this certificate is that so there are some fundamental courses that you take in the Bachelor of Bachelor Science of Electrical Engineering. But when you take these electives, you will be familiar with all of those material that you have to know when you go to an industry which is heavily based on instrumentation and control. So from these pictures, you could easily see that in so many refineries that when you go, there are so many instrumentation and control stuff that would confuse you. You don't know what they are, and you have to get a lot of training so to even know what they are, okay? So what this certificate is gonna help you with is to just know these materials, to know how to deal with them, to just recognize them, go through the maps and find out that what is the task of each of these modules are, and so on. So this certificate has been given more than 3 years to our students. There's been a lot of success stories from our students who got this certificate, went to the job, and just like when they went there and said, "Hey, I have this certificate," everybody was surprised and excited, and some of them got raises right away just because the company didn't need to give them a lot of training, and they become very great assets to the industries, especially the ones around Lamar University. So that was it for me, and I would love to answer any questions if there is any.
Well, thank you for that. And it looks like we have a couple questions that I am just gonna read out loud, and I will let y'all decide which one of those is the better one to take it. So Kendall would like to know, do we do any PCB designing? And if so, what projects or experiments could we do that require PCB designs? And what softwares do you use for generating Gerber files?
So I can answer that. What you need is to take courses based on the circuit design, which is or circuits 1, circuits 2, and electronics design. And then besides that, if your PCB is like a digital circuit, then we have the microcontroller course, the course which is based on the microcontroller design. And then by taking those, you'll be ready to design the schematics, which is the basic of the of your board. And then, so you know, PCBs are printed circuit boards for the rest of the audience. So and this is a very good question. So so when you have your schematics, then you have to use a media. So like one of the best ones available in the market right now is Eagle, which is a product by the Autodesk, the one who is making the AutoCAD for those who do mechanical design, for example. And so basically, when you transfer your design to the schematics part of the Eagle, then you'll have the option to design your PCB. This is a very straightforward process. Once you know the knowledge of the design of the electronics, the rest of it, the design part of it, is just like some graphics that you could do in the software. So, Dr. Tcheslavski, I believe that we don't have a direct course that teaches PCB design because we consider it as like a technology level. But someone like me would be very happy to give you a crash course in just 2 hours. Of course, after you pass the required courses, just like microcontrollers, electronics 1, electronics 2, just come to my office and say, hey, here is my Eagle. And you get the Eagle for free from the website. It has like a educational version, which is free. You just get it for free, bring it on your laptop to my office. I give you a crash course in just 2 hours. You'll be able to complete the design of your PCB.
And the next question Kendall asked is networking covered at all within the electrical engineering field, or does that apply more to network engineering?
Let me answer this question. And in order to do that, let me go back to my presentation. Here it is. Well, first of all, Hassan, thank you very much for your roundup on your research. And I need to kind of step aside for a moment and say that perhaps you're a little bit confused by now. You came to learn about the department, yet we're talking about research. What does it have? What does it mean for you? See, well, first of all, by doing research, we stay on top of current technology. We stay on top of current knowledge. So the courses we teach you are based on current knowledge, current state of arts. We constantly improve, we constantly modify our courses. Also, if you look at our department, see how diverse our research is, which means that we can teach you virtually anything, including networking, because, well, we have Dr. Wang, who is a specialist in networking. And, well, just to brag about our previous students, this is not complete by any means list of companies where our, well, ex-students work. Just picture out almost any technological company. Intel, well, we have people working on them. Macintosh, yes, we do. Honeywell, whatever. So our students work there. And of course, well, this is old slide, but up to recent, it was still accurate. So about half of our graduates go and work at petrochemical because, well, industries are around. Some go to grad school, some go to control, and by now we have bigger percentage going into control simply because we have this certificate. And some go and work for power companies, energy, for instance. Now, what does it take to become electrical engineer? And I didn't answer this question about networking simply because, well, it's one of our courses here in our curriculum. Yes, you will have a chance to take networking course. But looking at our degree map, you may notice, well, first of all, there are many math and physics courses. Well, math is necessary, fortunately or unfortunately, but this is the case. We are very heavily using math in our discipline. Physics, well, as I mentioned, Dr. Barim is almost part of our department simply because engineering can be viewed as an applied physics. So therefore, physics principles that you learn with their department will be applied here at our department. And you may notice that, well, you take all these courses, and well, apart from intro to double E that you take very first semester, where you will be introduced to specific software, hardware, I don't see any semester of second year, spring semester, where all of a sudden you hit circuits, digital logic, and junior year is when you take electrical engineering courses, including all this good stuff with electronics, electromagnetics, microcomputers 1 and 2, and so on. Now, of course, climax of your, well, years here would be your senior design project that you take in last year. This, guys, this will take well, quite a big chunk of your time, energy, and dedication. And by the way, I believe this Friday we'll have Senior Design Symposium. I would highly encourage you to attend it virtually and see what sort of projects our senior students come up with, and what kind of equipment, what kind of systems they build, how they well, benefit from our program. Also, you may notice that you have 3 so-called alien elective courses, and this is what Dr. Zargarzadeh was talking about when he mentioned certificate. So if you take certain courses out of senior electives, and by the way, 2 of them cover networking. So there's a Computer Networks 1 and Computer Networks 2, if you are interested in networks, that you can take as a part of our curriculum. But there are also other courses that are part of control certificate, instrumentation and control certificate. However, there is one course very important. And by the way, our total degree takes 120 hours to complete. This is what state mandates that I think you can take in state of Texas. 120 hours. Coming back to my to me mentioning that there is one class missing, and this class is very important. Can you guess what it is? It's internship or co-op. See what happens during your senior years, well, senior and junior years, we highly encourage you to seek internship or co-op at local companies that hire electrical engineers. And this way you get all possible hands-on experience. And this increases your chances to land at a very good position tremendously. So therefore, we highly encourage and support. But in the past, interns and co-ops were coming with the price. And this price was the student who would be willing to take internship or co-op would end up pretty much losing the entire year. Because what happens, you take a co-op with a company, you are employed for 40 hours a week, and of course this is during work hours, 8 to 5, so you could not attend the class, and you would have to, well, basically drop school for one semester. When you come back from this co-op or internship, all of a sudden, okay, let's say you're here, spring semester of your third year, you look at your courses, electronics 2, oh, okay, fine, I'll take electronics 2, but it has a prerequisite of electronics 1 that you missed due to internship. Same with microcomputers 2, same with power. Well, all our courses are well structured. The sequence is well structured. Upper division courses have lower division courses as prerequisites. You cannot fall, for instance, fundamentals of power before you take electromagnetics. It simply wouldn't work. And therefore, students in the past had to miss the whole year. Now, what we did to better serve our students, we actually moved to an alternative content delivery mode, if you wish, which is hybrid. And this mode was basically designed to support internships and co-ops and full-time jobs and students outside of area who, well, for instance, cannot stay in a dorm and just don't have means to drive, say, from Houston every day. So what we did, we, every class, instructors in every class carefully designed materials suitable and capable for online delivery. And all your tests are designed this way that, well, you take them online. Your assignments, once you submit it, so you submit them online. Even labs are done online using a very specific, very, well, still kind of unique for EE programs hardware kit that, well, we ask our students to buy and use. And this kit is used almost in every single course that we teach. This gives you hands-on experience. This gives you understanding how electrical tools, electrical instruments are used, how to measure actual signals, how to generate them, and so on. You can find more information on these websites if you are interested, or you can send me email. This is my address. I don't expect you to remember it, but you can, well, find me on our website. Now, does it mean that our program is online? No, it does not. In every class, and of course before the virus, we were meeting on campus in class once a week, and we would have extra discussion. We would go over extra problems, answer questions, and so on. So therefore, technically speaking, our program is still face-to-face. But if you have valid reason to be off campus, if you have time conflict, you can petition to be, well, what we call hybrid exempt, and this would make you 100% online student. You would participate in all these sections or sessions remotely. So, and I believe this is it. This is all my presentation.
It looks like we have another question from Kelsey, and she wants to know when you can get involved in research. Is there a course classification? Like, do you have to be a freshman or sophomore? I mean, I guess you have to be at least a freshman, but.
The earlier the better. Come to our office first day of class. Tell us, okay, I'm interested in research. We will be glad to direct you. Dr. Zargarzadeh, are you? So yeah.
Yes, yeah, anytime. There is no, especially in the robotics projects, there is no time, a certain time that say you would like to start anytime. There is, you could start with robots, do something, or like start with the simple robot, or be a and just do a module, be involved in a module of a bigger robot, and yeah, you're always welcome to my lab if you would like.
My research is somewhat more, well, involved. So assumes students are having basic knowledge of signal systems they're handling. But other than that, we can find something to start. Okay.
Okay, I'm going to ask one question that I get asked a lot. It's a little more elementary than most of these questions, but going to job fairs and things like that, I often get asked exactly what is the difference between mechanical and electrical engineering, and how do you decide which one you want to do?
For me, the difference was, okay, I don't want to be disrespectful, but I mean, think about mechanical systems. Apart from the thing that you have heavy rotating parts which may hurt you, apart from the thing that, well, you need to lubricate something, so you may be covered by grease, but I mean, I'm joking, I'm exaggerating. To me, electrical engineering is somewhat more conceptual in the way that it's not always possible to touch what you designed, because sometimes your design is purely theoretical, especially if you're designing, say, an algorithm to control a robot. But again, in many practical situations, of course, you build actual piece of equipment. But for me, this is the main difference between mechanical and electrical engineering.
Okay, and I have one more question. Another thing, I deal with a lot of the companies that are looking for co-ops and internships, and we are always told that we have a very good reputation at Lamar for our electrical engineers. So what do you think makes Lamar University stand apart in the electrical engineering department, and why are our students coming out, so ready for the industry?
Well, perhaps part is the certificate that Dr. Zargarzadeh mentioned. We are trying to stay modern. We're trying to stay contemporary. We are modernizing our program, well, almost every semester. We are making changes. Also, I mentioned that we have a very broad variety of faculty. In terms of their specialty, in terms of research. So therefore, students can actually specialize, can find specialty in, well, basically any area of electrical engineering, and can find an expert here locally. The other reason is perhaps more related to Lamar in general and our college. Our college is still fairly small, which means that student to faculty ratio is not as large as, well, at bigger schools, UT for instance. And I mean, professors, we teach our courses. We don't send our graduate students to instruct. And again, this probably has both good and bad consequences. The good is that we are very accessible for students. You don't need to, well, despite current situation with the virus, but in the past, you never had to line up in a line next to somebody's office waiting for 10 minutes for office hours. Again, depending on the faculty, my office hour policy was always very simple. You corner me in the corridor. This is when I have office hours. You found me in the office. let's have office hours. You have questions, sure. You send me email whenever time it is. If I'm up and next to my computer, I'll answer it. So accessibility is a big part. Perhaps somewhat bad situation is that with age, we probably get less exciting. So I noticed that for me, now it's probably somewhat harder to excite students in my research than it used to be 10 years ago. And this is why Dr. Zargarzadeh is here to excite you about his research area, because he's younger and more energetic. So every coin has two sides, right?
Well, thank you so much for answering that. And I want to say thank you to Dr. Tcheslavski and Dr. Zargarzadeh for being here with us today. I think I learned a lot about electrical engineering. Hopefully everyone watching did too. I am going to share with you our contact information. Give me just a second. What do I want to share? Let's see. There we go. Okay. So this is the contact information for me and Dr. Tcheslavski. If you have any questions, feel free to email us. You can also go to lamar.edu/admissions/find your admissions counselor. Again, if you have any questions just about general Lamar admissions. Dr. Tcheslavski mentioned we are having our senior design symposium this Friday. It's a virtual event. So basically, obviously, we can't show all of our designs in person this year. So you'll be able to log on to our website and look at the different designs. And you can look at all the electrical designs if that's something you're interested in. If you go to our Facebook page, which is Lamar University College of Engineering, you'll see information about that and how to log in on Friday and check that out. Once again, if you have any questions, feel free to email us. We would love to get in touch with you. And if you want to leave your email in the chat, I will be happy to reach back out. And that is it for me.
Thank you.